Hi guys, this is Mom Bawb. We're going to do Unit 8 Lesson 1 and Unit 8 Lesson 2. This is linear and exponential sequences. We're talking about sequences in this lesson, and to warn you, I don't have a math brain. I hated learning this because some of it worked for my brain and some of it I'm like, I just don't get it. So a sequence is an ordered list of numbers, and it gives all of these examples and then wants to know if you can figure out the next term in the sequences shown. So the first one is 2, 4, 6, 8, 10. Obviously they're doing even numbers or counting by twos, so the next one would be 12. This one makes sense to me. I'm fine with this. The next is 5, 25, 125, 625. This is not just obvious to me. Maybe it's like 5 times 5 and then 25. I don't know because I don't do big multiplication numbers. Whatever. I don't care. But that's the lesson. Then we have 1, 4, 9, 16, 25. I have no idea. None whatsoever. Like, what? Then we have 4, 7, 10, 13, 16. Okay, this is fine. 4 plus 3 is 7, 7 plus 3 is 10, 10 plus 3 is 13, 13 plus 3 is 16. I can do this. 0, 2, 2, 4, 6, 10, 16. This one, before I learned this in algebra, would have been complete garbage to me. I know how to do it now because I suffered through this, but yeah, this is just trash. And basically they're just trying to teach you to pick out patterns and to figure out what the pattern is. And yeah, basically this is 0 plus 2 is 2, 2 plus 2 is 4, 2 plus 4 is 6, 4 plus 6 is 10, 6 plus 10 is 16. Why this matters, I have no idea, but you do have to do a quick check and a practice, so I guess that's why we're doing this. A recursive formula is a formula expressing any term of a sequence or series after a stated term as a function of preceding terms. I love definitions like this. Basically, this is saying this is a formula that tells you what term is going to come next in like a series of numbers like we just looked at based on the numbers that they've given you. Okay, but they had to make it really complicated. It identifies the pattern of the sequence and can be used to list the terms of a sequence in order. So this should probably be in your notes because they're going to keep referring to two different types of formulas. So especially these last two things that actually make sense and, have some merit is it identifies the pattern of the sequence and can be used to list the terms of a sequence in order. That's a recursive formula. The other type of formula we're going to look at is an explicit formula, which defines a general term. An explicit formula defines a general term of a sequence. It can be used to find, for example, the 100th term of a sequence without first knowing the 99th term by substituting 100 for the term number variable in the formula. So this is useful when a question wants to know what the 100th term of a sequence is, and you don't want to go, okay, first is 1, then 2, then 3, then 4, then 5, then 6, and 7. It simplifies it and makes it faster to find your answer. A sequence is a list of numbers that follow a specific pattern or formula. They are not random, even though sometimes they may look like they are. There is a pattern. For example, if you're planting a garden and you're planting the plants 3 inches away from each other, then the first plant is going to be 3 inches from the edge of the garden, then 6 inches from the edge of the garden, then 9 inches, then 12 inches. If you have a bank account that's accruing 10% annually, you'll start with $100. The next year you'll have $110, then $121, then $133.10, then $146.41. Terms are the numbers in a sequence. So 3 is a term, 9 is a term in this sequence. These 3 dots at the end of these sequences, there should be 3 dots over here, but I ran out of room. This is called an ellipsis, and it means that the sequence continues forever. So if you haven't seen that before, that's what that means. And I took a break to go do dishes, so I can't remember if I said this is the beginning of Unit 8, Lesson 2. Most sequences have some pattern or rule that tells you how to determine any term in the sequence. So the first thing you do is give the first term, the first thing they do is give the first term. And the second is to give a rule for determining the next term from that first term. So an example is the first term is 7, and then you get the next term by adding 0.5 to the previous term. So if our first term is 7, then we're going to add 0.5 to get the next term. So that would mean we have 7, and the next term is 7.5. Does that make sense? Okay. So, and then you would add 0.5, so the next term would be 8. Add 0.5, the next term would be 8.5, and that would just continue on. Okay. The index is the position of a term in the sequence. So this is a table showing the pattern that we just did. The index, or n, is like 1, 2, 3, 4. This is the first term, the second term, the third term, the fourth term. And then these are the numbers we were just talking about: 7, 7.5, 8, 8.5. The sequence is adding 0.5 each time. So if you wanted to know what the third term is, you'd go find the number 3 on the index and go down, so it would be 8. So if we wanted to find what the 10th shoe size is, this is patterns and shoe sizes, then we would just continue this table, continue filling out this table until we can find what the index for 10 is. So if we continue the table, then we can see that the index for 10 is size 11.5. Now, if you wanted to find what the 50th term is, you could just continue this table forever, but I mean, that's a lot of math. So what you would do instead is you would calculate the nth term as a function of n, and we'll figure out how to do that in a little bit. The shoe size sequence, which involves adding a constant of 0.5 to determine the next term, is an example of an arithmetic sequence. The constant can be any real number, whole or fractional, positive or negative. In this case, the constant was 0.5. There is another way to figure out what the difference is. It's called the common difference, and it's between any term and the term before it. So you would just take two terms that are next to each other from your table, for example 7.5 and 7, and you would subtract them from each other and find the difference, which is 0.5. If you went to another two terms that are next to each other, 9.0 and 8.5, it's still 0.5. It doesn't matter which two terms you use for the previous table we were using, it's always going to be, the difference is going to be 0.5. So if you're given a sequence of numbers, you can determine the difference between pairs of adjacent terms by subtracting each term from the term after it. If the difference is constant, it's an arithmetic sequence. So if the difference doesn't change, if it's always the same number, it's an arithmetic sequence. And there's a definition for arithmetic sequence that you can put in your notes. In order to determine the next term in the sequence, all you do is add that constant difference to the number, the last number that you have. Addition and subtraction are inverse operations, which means they undo one another. So if we take our last number, let's say our last number is 7.5, and add 0.5 to it, the next number in the sequence is going to be 8. A geometric sequence, you multiply by a constant instead of adding, like with an arithmetic sequence. I can't remember if it was arithmetic or... Yes, it's arithmetic. I didn't know if it was arithmetic or algebraic. I'm so good. An example of this is this sequence where 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. When we're dealing with a geometric sequence, we have a common ratio, which means between adjacent terms, there is a comparison by division. Example, 2 to 1, okay, or just 2, which means that they're being divided in half or multiplied by 2 because everything has an inverse, everything flip-flops. Addition and subtraction with arithmetic, multiplication and division with geometric. So for this one, I'll draw a table. So here's a table showing what we were just talking about. Here's the index, or n. It's just the first term, second term, third term, fourth term, fifth term. Here's the rule. Everything's being multiplied by 2. So this is just our first given term. And then it's 2 multiplied by 2, 4 multiplied by 2, 8 multiplied by 2, 16 multiplied by 2. So here's all of our table. And if you look at this, if we take 4 divided by 2, 4 divided by 2 is going to give us this 2 back here. So 4 divided by 2 is going to give us 2 if you're working backwards down the table. 8 divided by 2 is going to give us 4, so you can work either way on the table. To determine the next term, you're going to multiply by the ratio, which in this case is 2. To determine the previous term, you're going to divide by the ratio, which is 2. So if we want to figure out what the 8th term is for this sequence, all we would do is continue the table to find the 8th term. So here's that table for you. Go ahead and pause the video and figure out what the answer is to the 8th term. And this is what your table should look like. So the 8th term is going to be 256. As with arithmetic sequences, the constant factor of a geometric system can be any real number, whole or fractional, positive or negative. Here's an example of a complicated sequence that I would absolutely hate to try to figure out on my own. The constant factor is negative 0.8. And it goes 625, negative 500, 400, negative 320, 256, negative 204.8. The only part of this that makes sense to my non-math brain is that this must be geometric because it's flipping from positive to negative every time, so it's multiplying by a negative. So positive times a negative gives you a negative, negative times a negative gives you a positive, positive times a negative gives you a negative. That's the only part of this that clicks in my brain. For the following arithmetic sequence, A, determine the rule for generating the next term, and B, the next 3 terms. If terms are fractional, write them as fractions in simplest form rather than mixed numbers or decimals. Because it's an arithmetic sequence, that means we're going to be adding, subtracting. Okay? Pause the video, go ahead and see if you can figure it out. The first thing I did was make a table, and then I did addition and subtraction to figure out the difference between adjacent terms. So 24 minus 19 is 5, 19 minus 14 is 5, 14 minus 9 is 5. So our constant is negative 5. I don't need this table, but we're going to continue it because I'm very, very left-brained and I like things nice and organized. And here is the rest of it. So 5 would be 9 minus 5, which is 4. Here's my math here. The 6th term would be, 4 minus 5, which is negative 1. And the 7th term would be negative 1 minus 5, which is negative 6. For the following geometric sequence, determine A, the rule for generating the next term, and B, the next 3 terms. If terms are fractional, write them as fractions in simplest form rather than mixed numbers or decimals. We have 81, 54, 36, and 24. Because it's a geometric sequence, we're going to be dealing with multiplication and division. Pause, go ahead and figure the problem out. This is just to show you how bad I am at math and that I don't have a math brain and why I hate this. This is all wrong. If this is going to screw you up, don't watch this, but I want to make you feel better. So what I did first was I just took the difference between the two numbers to see if I could find a pattern there. And what I found out was that we had a difference of 27, a difference of 18, and a difference of 12. So these are both have a common denominator or a common divisor or whatever of 9. And these have like 6 and 3. So I figured 3 would go for all of them. So I divided each number by 3 and found out we got the same answers here, which is like, okay, well, that's interesting. I don't know why. So then I was like, well, maybe it's just each number times 3, and that doesn't work because 24 times 3 is 32, not 36. And I am completely stuck at this point. I have no idea where to go from this. So I'm going to have to go and look and see what the answer is and try to figure it out. This is why I wish that people who didn't have math brains would make these lessons, because to them it's so obvious what the pattern is, but I really have no clue, like none whatsoever. Okay, our magical constant is 2/3. Now, how I'm supposed to know that, I have no clue. How I'm supposed to determine that, I have no clue. But if that helps you, go ahead and figure out the next 3 terms based on 2/3. I'm sorry that I can't help you more than that, because the lesson doesn't help me more than that. They assume that you can look at this and go, oh, well, 54 is 2/3 of 81. What? Oh, wait, it does explain it. It says that if you take like 24 and divide it by 36, that it's going to give you 2/3. So maybe I was supposed to know that and I'm just too dumb? I don't really know. But 24 divided by 36 is apparently 2/3. 36 divided by 54 is apparently 2/3. 54 divided by 81 is apparently 2/3. So I guess you take bottom number divided by top number and it will give you your ratio, I guess. Okay, so basing it off of, we can take this divided by this and get our 2/3. Then I just took our last number and multiplied it by 2/3. When you're multiplying a fraction, you just multiply straight across. So this is really 24 over 1. So it's 24 times 2 is 48. 1 times 3 is 3. And if you put that in your calculator and divide it, it turns out to be 16. I wouldn't have known that off my head. So then we take this last number, bring it down here, and multiply it by 2/3. So 16 times 2 is 32. 1 times 3 is 3. This doesn't reduce any further. So then we take this number, bring it here, multiply it by 2/3, and we get 32 times 2 is 64. 3 times 3 is 9, and that doesn't reduce anymore. So our next 3 numbers are 16 32/3 and 64/9. This is practice question number 1. It wants to know if this sequence is an arithmetic sequence or a geometric sequence. So pause the video, figure it out, come back. And here's how I figured this out. So I just found the difference between them first. So 8 minus 3 is 5, 13 minus 8 is 5, 18 minus 13 is 5. We have our constant already. We have our answer. The constant is 5, and it's an arithmetic problem because it's addition and subtraction.